Has this ever happened to you? You're just juggling a regular 3-ball cascade when someone asks you,
what's the physics involved in that? What?
Let's start off simple with a 3-ball cascade. You may be wondering, what's the physics involved in a 3-ball cascade? Excellent question. Now let's get started. As you can see, my clone is juggling a 3-ball cascade, and very well, I might say. So at the beginning, the prop wants to stay at rest since it's not moving yet. Makes sense. But then, once you toss that first throw, it wants to keep going in motion upwards. But eventually gravity kicks in, and gravity is pretty strong, so once it peaks, usually about your eyes or the top of your head, but it all depends on how hard you threw the prop. But once it peaks, it wants to keep going down for as long as it can, but your other hand stops it from going any further. And that process keeps going for as long as you throw the 3-ball cascade. Nice job. Now you're good to go. How do you draw a free body diagram for that? Great question. So, first, what you want to do is put a dot in the middle of your paper to represent the center of the object that you're trying to draw the free body diagram for. So first, put a gravitational force going down, since we're on the Earth, so a gravitational force is always present, so say F sub g, and now put an applied force going up and to the left, because that's the way that you're throwing the prop. Cool. Now let's look at the physics involved in a 3-ball cascade, but with a drop at the end. No. Just no. Stop it. Stop it. Oh my gosh. Anyway. Here we go. So as you can see, my clone is trying to throw a 3-ball cascade, but, well, looks like you dropped one. It's a shame. So let's look at the physics involved in that drop. So the beginning physics is all the same with the first toss and the rest of the throws, but the end is ever so slightly different. Instead of it wanting to stay at rest when it reaches your hand, it wants to stay at rest once it reaches the floor. That's it. How do you draw a free body diagram for that? Great question. So, for this problem, there are 2 different free body diagrams. So let's split the page in 2, and this one will be our first one, and this one will be our second one. So the first one is for when the prop is suspended in the air about to hit the ground, but hasn't quite hit the ground yet. So you put your dot, as you always do, and you put your gravitational, as you always do. Let's say F sub g. And that's it. There's no normal force because there's no surface involved with this problem at all. So we're done with number 1. Alright, now for number 2. So, first what you want to do is you want to put your dot and your gravitational, as you always do. And now, a normal force. You want to make sure that your normal force is longer than your gravitational force. Now you're good to go. Congratulations. Alright, now it's time for my third and last example. It's basically like juggling a 3-ball cascade, but in reverse. It's juggling with silicone balls on the ground.
You said balls.
Anyway, get to it. Get juggling. Alright, so now let's take a look at the physics involved in a reverse 3-ball cascade, as my clone is demonstrating pretty well right here. So let's take a look. So at first, the prop wants to stay at rest in your dominant hand, whichever that may be, since it's not moving. So next comes the first throw. Now we're used to the first throw going up, since that's the way people normally juggle. But not in this case. In this case, the first throw is down because it's reverse juggling. So the ball or prop wants to keep moving down, but it's stopped when it hits the ground. And then once it hits the ground, it wants to stay at rest for that split second that it hits the ground. So once it hits the ground, since it's a very bouncy material, it wants to go up. So it does. But it can't go up forever because your other hand catches it. And that process keeps going for as long as you throw the reverse 3-ball cascade. Cool. How do you draw a free body diagram for that? Now it's time for our third and last free body diagram description. So, first what you want to do is put your point and your gravitational force going down, F sub g, and now your normal force going up. You want to make the normal force slightly shorter than the gravitational force for this problem. And now you're done. Now you know how to draw a free body diagram for 3 different types of juggling. Congratulations. Thank you guys so much for watching that video. I really hope you liked it. It really means a lot to me, all your views and subscriptions. But anyway, so if you liked it, please make sure to give it a like and consider subscribing to my channel down below. And also click the little bell icon so that you can be sure to be notified whenever I upload stuff. And like, share, and comment down below as to what kind of stuff you want to see me do in 2017. I already have some stuff planned out for the not too distant future, possibly impression videos or covers. So keep an eye out for that. And I think that just about does it. Have a wonderful day, everyone. Bye.